Hello guys. Today we are going to do part 2 of lesson 8.3. We're talking about asymptotes, points of discontinuity. Today we're going to do the horizontal ones, and these are actually much easier than the vertical asymptotes and the holes. So in this box right here, it's the rule for finding out if there are horizontal asymptotes and if there are, what they are, okay? And so here's one of the most important things you need to know. There can only be one horizontal asymptote for any rational equation. There can only be one, if there is one. Some of them don't have one at all. So here is the rule for finding out, okay? All you have to look at is the degree of the top and the degree of the bottom, okay? So that's good news because these do not have to be factored. And so factoring is the hard part. So we basically cut out the hard part. All right, so here are the three cases. So write this down. This is case 1. This is case 2. This is case 3. Okay, so with the degrees, there are three things that could happen, okay? So one of these three things will happen. If the degree of the numerator, now remember that's the top, is less than the degree of the denominator, that's the bottom. So if the degree on the top is smaller than the degree on the bottom. So now remember, we're only talking about degree here. Then there is a horizontal asymptote, and the horizontal asymptote is at y equals 0. Now, y equals 0 is the x-axis. See, y equals 1 would be here. Remember, y equations are horizontal, hoivux, right? And y equals 2 would be here, and y equals -1 would be down here. Y equals 0 is this x-axis. Y equals 0. Okay, so if the smaller degree is on the top, the bigger degree is on the bottom, there is a horizontal asymptote and it's at y equals 0. The second case, if the degree of the numerator, which remember is the top, is bigger than the degree of the denominator, which is the bottom. So in other words, if the bigger degree is on the top and the smaller degree is on the bottom, there isn't one. So there is no horizontal asymptote. And then finally, what could happen is what if they're equal? It says if the degree of the numerator, the top number, is equals the degree of the denominator, the bottom. So if the top degree equals the bottom degree, so same. They're equal degree, the same degree. Then there is a horizontal asymptote, and it's at this equation, y equals a over b. Now, we need to know what a and b are. A and b are the leading coefficients, the leading numbers of those two parts. So, like down here, the 2 and the 5, those are the leading numbers, and you just write a fraction. Okay, so if it's a smaller degree over a bigger degree, there is one at y equals 0. If it's a bigger degree over a smaller degree, then there is none. And if they're the same degree, top and bottom, then it's y equals a over b, where a and b are these leading numbers. And so all you have to know is the degrees. You just have to compare the degrees. They don't have to be factored. In fact, we would like them unfactored to be able to see their degrees a little better. All right, so now we're going to do some examples. I was going to raise this so you can see everything at once, but all right, anyway. So here is our equation. They want us to find the horizontal asymptotes. All we have to do is look at the degree. So this x by itself is x to the 1. This is x to the 2. So it's a smaller degree on the top. It's a bigger degree on the bottom. And so there is a horizontal asymptote. There is one, and it is at y equals 0. So remember, that's not the solution to this. This is just where there's a horizontal asymptote. And then for this one, Now, anytime you want to, you can pause this video and then try them and then see if you get them right. You can press play again and see if you get them right. All right, so look at this one. All you're looking for is the degree. This has degree 2, this has degree 2, and so they're the same. Same degree on top and as bottom. So it's y equals a over b, and a and b are the leading coefficients of the numerator and the denominator. So the leading coefficient here is a 2, and the leading coefficient on the bottom is a 5. So that's a, that's b. Y equals 2/5. So there is a horizontal asymptote at y equals 2/5. So see, this is much easier. You just find the degree of the top, find the degree of the bottom. The degree of the top here is a 1 because it's 3x to the 1. The degree of the bottom here is 4x to the 1. Since they have the same degree on the top and the bottom, it's y equals 3/4. Now, the only thing that could get a little confusing about this is if you confuse the concept of horizontal asymptote with vertical asymptote. So remember, vertical asymptotes, you have to factor the bottom and set it equal to 0 and find out what those solutions are, and then you have to see if they cancel with something on the top. So that's a whole different process. That's vertical asymptotes. But horizontal asymptotes, all we care about is degree. So that's going to be the tough part to remember, is when you see the directions, knowing that horizontal asymptotes is just talking about degree. Okay, on this one, so the degree of the top is a 2, and the degree on the bottom, x to the 1. See, anytime you have just a plain x, it's to the 1 power. So we have the bigger one on the top, and we have the smaller one on the bottom. If you forget which one would be y equals 0 and which one means there's none, just refer back to this box right here. So if the bigger one's on the top and the smaller one's on the bottom, this one has no horizontal asymptote. No. Now, it doesn't mean it doesn't have a vertical one. So this could have a vertical one. But there's no horizontal one. So all you do is look at the degree to tell that. And then this one, again, we don't want to spend time factoring this. Don't factor the x squared minus 9. You would need to for vertical asymptotes to see if it cancels. But for horizontal ones, you're just looking at degree. So this top has degree 3, this bottom has degree 5. So it's a smaller degree on the top and a bigger degree on the bottom. And that means there is a horizontal asymptote at y equals 0. Always double check this to make sure you don't have those backwards. So smaller over bigger, y equals 0, bigger over smaller is none. Now, I give you, on the test over this stuff, I give you this little summary box. Because if you ever needed to know this for graphing or for something that had to be, horizontal asymptotes had to be figured out for, you could always refer to how to determine if something has horizontal asymptotes. So if you forget, then go back to this little chart, and that will be given to you on a test. All right, the only thing that's not mentioned in these notes is that what if it's factored form? Like, for example, what if they gave us number 4 and it was factored already? So let me just show you that. Suppose this was x plus 3, x minus 3, and this was x plus 3. So it's the same thing. It's just I factored the top, okay? Well, when they ask that question about horizontal asymptotes, you have to know degree, right? And the bottom's pretty easy, x to the 1, that's a degree 1. But you may not notice that since there's 2 x's here, that multiplied back again, see, this is factored, but foiled, you would get an x squared. So you have to think about that. If it's factored, you have to think, okay, if I were to multiply it, I would have x times x, and that's x squared. And then you look at the degree 2 and the degree 1, and you can see that the top is bigger than the bottom. So that's the only thing not mentioned in these examples, is that if it's factored, like if you had, let's say on the bottom you had an x and an x plus 3. It's factored, right? Well, that degree is 2. The degree is not that 1. The degree is 2 because when you FOIL or distribute this, when you distribute, you have an x squared, so the degree is 2. So it's possible that these are factored for you, and you have to kind of think about when you multiply them. All right, so let's go back to this for just a minute. Let's combine the two concepts all together. So since the degree on the top is degree 2, because x times x is x squared, and the degree on the bottom is 1, x to the 1, that means the top is bigger than the bottom, which means there's no horizontal asymptote. But let's look at other points of discontinuity. All right, so see how that's factored, and that's just x minus 3. What if this question asked us to talk about horizontal asymptotes and the other points of discontinuity, like vertical asymptotes and holes? Well, let's go back to just what we did last lesson, just to refresh your memory, okay? We know that something is happening at -3, at x equals -3. Because see, if we solved that, we would get -3. So there's a discontinuity at -3. There is no horizontal asymptote to this because the top degree is bigger than the bottom degree. But there is some kind of point of discontinuity at -3. And since it cancels, the x plus 3 cancels with the x plus 3, then we know what's happening there. There's a hole in this graph. So there is a hole at x equals -3 at this point. And let me just show you what this thing looks like. Since that canceled, now you don't have to write any of this down, I'm just talking to y'all. If that canceled, then we would just have y equals x minus 3, y equals x minus 3. And just think back to Algebra 1. We did it this year too, but really this is Algebra 1. That's a line right there. So remember you start at this last number? And the slope is 1, which is the same thing as 1 over 1. Now we're going way back here. 1 over 1, 1 over 1, 1 over 1. This thing's just a line, but we found out there's a hole at this point because it cancels. So at x equals -3, right about here, this line looked totally normal, but there's a hole right there. So see, no horizontal asymptote. We found no vertical asymptote because that line's going to keep going, and that line's going to keep going. It's not approaching anything that it's not going to cross. That's what an asymptote is. So yeah, the only thing we found there is a hole. So these methods, they work. That tells you that there's a point of discontinuity when you solve that. Knowing that it cancels tells you it's a hole. And the degree being higher on the top than on the bottom tells you that we did not have a horizontal asymptote on that problem. All right, so that kind of sums up the two lessons, the two parts of this lesson about rational equations. All right, so that is all there is to that. Y'all have a wonderful day.